Dr. Babasaheb Ambedkar, Open University.
Namaskar, dear students and learner of this course. I am Professor Kamesh Raval. I welcomes you in the video lecture series of Dr. Babasaheb Ambedkar, Open University. I think in the last session we have seen how can we convert the number, right, hexadecimal number into the octal, as well as how the octal number that can be converted into the hexadecimal number. We have also discussed a 4 different type of numbering system. Okay, so we know that what is a binary number system, what is the decimal number system, what is the octal number system, and finally what is hexadecimal number system. Okay. We have already discussed when we are giving a number, right, in the form of decimal, then that number will be converted into the binary format, and then the machine will process it in the form of binary, right. But is the binary is only method, or is there any other options are there? Yes, the other option is still there, which is known as a BCD. So in our today's session, we will just try to focus on a BCD. Right, we will just go into the detail of what actually the BCD is, right. Then we will see how can we represent the data, right. I think in the last session I have told you that our computer memory is actually made by our ICs, right. And in a one small IC, in a one small integrated circuits, there are small millions and billions of components are there, which is called capacitors or transistor, which we are considering as a electronic component. Now the thing is, you can charge that component or you can discharge. If you are charging, electron is there, it will represent 1. If you are discharging, electron is absent, it will represent 0. So we know that the machine's memory can store only all the data in the form of binary numbers, right. But once we are learning this thing, I think some question will arise into your mind, right. Sir, how ABCD or my name gets stored into the computer's memory? So fine, here in this topic I will try to give the answer of that question, right. Let's suppose if you are storing your name or your university's name or your study center's name, then how that data gets stored into the random access memory, because we know that the random access memory can store the data only in the form of binary. And up to here we have discussed how can we convert a binary from a given number, right. But how the alphabets that get translated into the binary, fine. So we are just coming to this point. We will see here how can we represent a data, how can we represent alphabet, how can we represent a string, okay. Then we will see how can we represent a numeric data, and then we will see what is actually a complement, right. How the computer is doing a subtraction and how the complements has been used in the subtraction, right. Fine. So let us start our today's session. We'll just go ahead with what actually the BCD is. So see, machine can understand only one language, and that is the language of ones and zero, which is known as a machine level language, low level language, or binary language, right. Okay. What we are doing, we are using a decimal number system in our day-to-day life, right. So whenever you are giving any kind of number, obviously we will enter it into the form of decimal, but that gets translated into the binary. So machine take data from the user, which will be converted into the binary, then that binary will be processed by the system. Again, the information which will be produced by the CPU, that is again into the binary form, and then output devices will just convert that thing into again decimal, and it is representing to us, right. Okay. So the thing is, apart from binary, is there any other method, alternative is there? Obviously yes, and that is nothing, it is called BCD. Now what is BCD? So here the BCD, which stands for binary coded decimals, right. Now what is binary coded decimal? The another name, the another alternative is what? BCD. BCD, which stands for binary coded decimal. Now here in the in the case of BCD, each digit of decimal that separately get translated into the form of binary. Now you know that let's suppose how many symbols are there in the decimal. You know, in the decimal number system we have 10 symbols, right? So if you want to convert, let's suppose this 5 or suppose 9, right, then how much bits has to be used? Let's suppose if we are using 3 bits, so how many symbols we can represent? Obviously 2 raised to 3, that is total 8 symbols. 8 symbols means 0 to 7. But in the decimal we are also considering, you know, 8, 9, etc., etc., right? So obviously 3 bits are not sufficient. So what we will do is we will use a 4 bits, right? 2 raised to 4 is what? Here with the help of 4 bits you can show, you can represent 2 raised to 4, that means 16 symbols. And in the decimal number system how many symbols we have? We have only 10 symbols, okay? So we need to use 4 bits to represent 1 digit of your decimal number system, right? So here, you know, 2 raised to 3, 3 bits are not sufficient, because with the help of 3 bit we can represent only 8 symbols, right? That's why in the octal number system we are actually satisfied with the 3 bits, right? Because in the octal number system there are only 8 symbols are there. But suppose if you want to represent a single digit in a binary format of a decimal number system, in the decimal number system we know that we have 10 symbols. So 3 bits are not sufficient, so we will use how many? 4 bits, okay? BCD is a more convenient way to represent a binary, right? The binaries, you know, compared to the binary, BCD is more convenient way to represent the thing, right? BCD use more memory. Obviously it will use a more memory, right? How? We are just coming to this point, right? For example, any number is given to you. Let's suppose the number, decimal number is given to you, that is 294, right? And you just need to convert it into the binary. What you need to do is, binary, if you want to count, then you need to write that number like this, 294, and then, right, then you just need to divide that number by 2 every time, unless and until this number will not becomes 0, right? So you just need to divide this number by 2, because we want to compute a binary. So this is binary, right? Here we are writing 1, then 2 4s are 8, but you know we have 9, so here 1 is there, so 2 7s are 14, so here 147. Because this number is an even number, so we will just keep a remainder to 0. Again we will just divide this one, this number 147 by 2, and we will just going ahead, and then whatever remainders are there, that all remainders we will write into this way, right? So that is how the number gets converted into the binary, right? If you are collecting or writing all the remainders, right, unless and until this number will not becomes 0, that is called the binary. But here we are not talking about binary, we are talking about what? We are talking about BCD, right? So here, you know, 294, so this is a 3-digit number, you just write it down into this way, 2, then 9 and 4. Now write down the binary of 4. So you know, 1 is not there, 2 is not there, 4 is there, and 8 is not there, right? Because we want to represent 4. So here I have written a binary of 4. Similarly here 8 plus 1, right? So 8 is there and 1 is there, 2 and 4 is not there, right? So these 2 are 0, 2 and 4s are 0, 1, right, and 8 is there. So 8 plus 1 makes 9, right? Similarly 2, so here 8 and 4 and 1 is not there, only this 2 is there, okay? So this is what? It's the binary of 2. So see here, individual, each and every digit will be returned in the form of 4 bits of binary, right? And this is called BCD, right? So now you just try to compute this thing into the form of binary, right? You will get, or you need to use a less number of bits. But you know, in the case of BCD, we are using more bits, and obviously if you are using more bits you need a more memory, right? So obviously the BCD uses more memory than the binary, but it is much more convenient, right? And that's why in our computer and engineering and computer science stream, BCD is used. Okay, let's suppose here I have given a comparison, right? Let's suppose if you have a number called 173, so how can you convert that thing into the form of BCD? So here if you want to convert this number into the form of BCD, you just need to write it down this 1, then 7 and 3 digit number is there, then you write it down a binary of 3 in the 4 bits, right? You write a binary of 7 again by using 4 bits, and write a binary of 1 again using 4 bits. If you are writing all the things together, it will be a BCD. But let's suppose if you want to convert this, right, 173 into the binary, you need to do this process, right? Already we have done a lot of examples of how the decimal number gets converted into the binary. So I'm not going into the detail of that thing, but this is what a binary number. You just count, here less bits are there, here more bits are there. So BCD uses more memory, but the thing is, it is more convenient than the binary. So in our computer we are using BCD. Okay. Now the question, that is, let's suppose it's okay sir, whenever any number is given to us, we need to convert it into the form of either BCD or binary, and how to convert it into the BCD or binary, that we have already discussed, so we know that, right? But now suppose if any type of question arise in your mind, sir, my name is let ABC, right? My name is ABC, and if I want to store my name into the computer's memory, can I store it? Obviously yes, right? So you can also store the ABC, right? Now the another question will comes into your mind, sir, you told us that everything into the computer's memory gets stored in the form of binary, right? And we can easily convert, if the number is given to us, then we can easily convert that number into the binary. But sorry, how can we convert this ABC into a binary, right? So obviously can we compute a binary of A? Obviously not, right? How one person can divide the A by 2? Can we divide A by 2? Do you know how can we do this type of division? No, obviously no, right? So we cannot compute the binary of characters, of symbols, right? Or special symbol, right? Like @ dot, plus sign, minus sign, and so on. Then how this type of symbols or alphabet gets stored into the computer's memory, right? So here each and every symbols, whatever are available on the keyboard, they are represented into the number form. Why number form? Because we can find it out the binary of the numbers, not the alphabets, right? So let's suppose if you are talking about A, so A has its unique number, right? Let's suppose if you are talking about a small a, so the small a will be represented as a 97, okay? Whenever you are trying to store a small a into the computer's memory, actually the computer stores the binary of 97. Let's suppose if you want to store a small b, this symbol, right, into the computer's memory, at that time the computer stores a binary of 98, okay? Similarly, C is there. If you are storing C, it will store 99, right? Suppose if you are storing capital A, right, then the computer will store a binary of 65, right? If someone wants to store capital B, then the computer will store the binary of 66 into the memory, okay? And in that way all the alphabets are separated or gets converted into the binary, right? So the thing is, whatever symbols we have on the keyboard, whether it is capital A or capital B or capital C, capital Z, small a, small b, small z, right? Hash, @ caret sign, dollar, space, semicolon, single quote, double quote, that every symbol has a unique number, and by using that number the computer gets translate that number into the form of binary. Now why we need that number? Because the machine can understand what? Only numbers, only binaries, right? And we can compute the binary of what? We can compute the binary only of numbers, right? So each symbol has its own unique number, and that number is called ASCII, right? So here ASCII is there, right? If someone is asking you A will be represented as a 97. So what is 97? 97 is the ASCII value of small a. 98 is what? It is the ASCII value of small b. 65 is what? It is the ASCII value of capital A, right? Now what is ASCII stands for? ASCII stands for American Standard Code for Information Interchange, right? Initially the ASCII is using 7 bits to represent any character, but nowadays we are using the latest version, the extended version of the ASCII, which use 8 bits to represent any symbol whatever is available on the keyboard, right? So this is what we have learned. How can we convert or how the characters will be represented in the computer's memory, right? Okay, now see here I have given a chart, capital A. So this is the binary of 65, capital B 66, capital C 67, and so on. Small a is 97, small b is 98, C is 99, and so on, right? Similarly here I have given some of the binary of ASCII values, right? Okay, now we have discussed how that characters or symbols, or the symbols whatever are available on the keyboard, get stored into the computer's memory, right? Now the thing is how the numbers will be represented, right? So let's suppose if you have some number, right? Then the number that has to be stored in this way. Let any number is given to you, that number will be stored in the form of n plus 1 bit. Now why n plus 1 bit? So obviously here the magnitude of that number gets stored, and here the 1 bit is used to represent the sign, okay? So let's suppose if any number is given to you, right, the value, suppose 45. So here the binary of 45 gets stored, right, in this area, fine. But 45 is a positive, plus 45, then here this sign bit will be 0. If sign bit is 0, that means here whatever number is there, it is a positive number. And suppose if the sign bit is 1, that means what? The number is a negative number, right? So here you can see the binary of suppose 45, then that 45 is a minus 45, is a negative number, right? Because here sign bit is 1. So see, whenever you have a n bit number, that n bit will actually represented in the form of computer's memory by using n plus 1 bit. Why 1 bit extra? Because we are not actually storing the value. Obviously to store the value we are using n bit, but n plus 1 bit will be used to represent the sign, right? If the sign bit is 0, that means the value whatever you are representing is a positive number. And suppose if the sign bit is 1, that means what? The number whatever you have returned from this 1 to n bit, it is a negative number, right? So that value is called a magnitude, and here 1 bit is used, it is called a sign bit, okay? Fine. Now complements. So what is the importance of the complements? So see, basically in the computer system we don't have any circuitry to do the subtraction, right? In the case of computer you know, let's suppose if you are writing something like this, let's 7, okay, minus 3, okay, then you know we are calling this operation as a subtraction, right? We are subtracting 3 from 7, but how the computer will understand this? Computer will understand 7 plus minus 3, okay, 7 plus minus 3. So, this is something computer will understand. Here I am having a binary of 7, I am having a binary of minus 3. So, binary of this, and I have to add both the thing, right. Computer is having only a one circuitry, and that is the circuitry of, we can say, addition, which is known as a adder. So, here the computer is actually understanding this particular expression into this way, 7 minus 3. So, this is, we are recognizing this operation as a subtraction operation, but computer will understand this operation as a 7 plus minus 3. So, minus 3 is a one number, 7 is another number, and computer wants to add both the number. So, the question is how we can represent this minus numbers. Obviously, to represent the minus number into the computer system, we are using complements, right. Now, how many type of complements are there? So, suppose if we will talk about any number system whose base is k, there are two type of complements are there, k minus 1th complement and kth complement, right. Now, you will understand, okay, sir, this is the things are not clear. So, we'll go ahead with the example. Let's suppose if you talk about a decimal system, right. So, in the decimal number system, what is the base of the decimal system? It is 10, okay. So, the base of the decimal numbering system is a 10. So, here 10 minus 1, so 9th complement has to be there for the decimal number system, and kth complement, that is 10th complement will be there, right. So, for the decimal number system, there are two type of complements are there, 10th and 9th complements, right. Okay. You just think binary, right. For the binary number system, how many different type of complements will be there. So, in the case of binary, there are only two symbols are there. So, base is 2, okay. So, 2's complement and 1's complement will be there, right. So, in the case of binary, we should have 2's complement and 1's complement. In the case of decimal number system, we should have 9th complement and 10th complement, right. Now, how to find a 9th complement? So, let us suppose if any number is given to you, right, 358. So, what you can do is, you subtract this number from 999, because why 999? Because your number is of how many? 3 digits. So, what is the maximum number of 3 digit? It is 999, right. So, you subtract your number from 999, you will get what? 641, and this is what it is, a 9th complement of this number, okay. How can we find a 10th complement? So, if you are adding 1 into the 9th complement, you will get 10th complement, right. So, here 358, what is the 9th complement of it? It is 641. So, suppose if you are adding 1 into a 641, what you have is, you have 642, and 642 is what? It is called a 10th complement of the given integer 358, okay. Fine. Now, in the next session, what we will do is, the things whatever we have learned here, right, the complements, we will try to use this thing, right, and we will try to perform a subtraction. I will show you a new method of the subtraction, right, not into the decimal system, but also into the binary system. So, first we will just see one or two example of how the subtraction can be done by using 9th and 10th complement, because 9th and 10th are the complement method of the decimal, and you people are already aware with the decimal number system, right, because you are using a decimal number system in your day-to-day life. So, we will just see how the subtraction can be done by using 9th and 10th complement, and then we will see how the computer actually do the subtraction of the binary numbers using 1s and 2s complement. So, in next 2 upcoming session, what we will do is we will try to discuss what is actually how the computer is doing addition, right, using a binary number, and how the subtraction will be done, right. Fine. So, that is it for the today's session. Okay, so in the next session we will see how computer do the arithmetics with the binary numbers, right. How the computer is doing addition of binary number, how the computer is doing a subtraction of 2 binary numbers using 1s and 2s complement. I think that is it for the today's session. We will meet in the next session. Till then, take care and bye bye.